Okay, this video is on solving systems of 3 variables, and we'll start with something a little bit easier than what they can be. The most famous method of solving systems is called Gaussian elimination, which uses elimination to get a system of 3 variables in triangular form. Triangular form is when you've got 3 variables, so you need 3 equations, and they don't have to be in this order, but triangular form is when one equation has one unknown, another equation has 2 unknowns, and a third equation has 3 unknowns. So this is triangular form, and if you write it in this order, 3, 2, 1, you'll see it makes a triangle. We can then use back substitution to solve for z. So when you have a system like this and one of the equation has one unknown, that's where you want to start, because you can easily solve for z by dividing by 2 and get z is 3. Well, now that we know z is 3, you can go back to this equation and put, instead of z, put 3 in, get negative y plus 9 equals 9. Negative y equals 0, so y is 0. And so now that you know z and y, you can go to this first equation and put in 0 for y and 3 for z and solve for x. So that would give you x plus 3 equals 7, or x is 4. And then again, don't ever forget to write it as an ordered triple. The order would be x, y, z. That's an ordered triple. So we have 4, 0, 3 is our solution. Alright, you might want to try this one. I'm going to solve for z. So z is negative 1/2, which means I can use it to find y in the second equation. So that would be 4 times negative 1/2 is minus 2, so y would be 2. So now I can use z and y to find x. 2x minus y, which would be minus 2, plus 6 times negative 1/2 equals 5, gives me, got to multiply these two together, that's negative 3. And then these are on the same side, so I'm going to add those using my addition rules. Negative 2 plus negative 3 is negative 5. So now I'm going to add 10 to both sides. I'm sorry, add 5 to both sides to get 2x equals 10. Divide by 2 to get x is 5. So the ordered triple would be 5 and then 2 and then negative 1, and don't forget your parentheses. So that's called back substitution. Alright, but they're not always that easy. The rules for Gaussian elimination can be a little tedious, so we're not going to teach you that or use that method anymore. But we may show you some matrices. So instead, we're just going to use the elimination method. Alright, so you can solve a system of 3 variables using the elimination method. It's just a little bit trickier. Alright, so this first example is actually a little easier than what they can be, because I'm just going to take a look at all 3. This one has x, y, z unknown. This one has x, y, z unknown, but this one only has an x and a z. The y is missing. So what I'm going to do is circle this one, because in general what you're going to be doing is you're going to have 3 equations with 3 unknowns. And you're going to want to get that down to 2 equations with 2 unknowns. And then you're going to want to get that 2 equations with 2 unknowns down to 1 equation with 1 unknown, and then you can solve it. Okay, so we need to get it from 3 equations with 3 unknowns down to 2 equations with 2 unknowns. And this is why this one's a little easier, because sometimes you have to do that twice, and you've already have 1 equation with a y missing. Okay, so basically that's just saying, hey, let's just take these 2 top equations and let's get rid of the y. Okay, so we want to get opposites. That's a 1y, that's a 1y. So I'm going to multiply this bottom one by -1. So I'm going to copy the top one down, and I'm going to write my understood ones, and I'm going to be very neat because I don't want to lose negatives. I'm going to multiply both sides of equation 2 by -1, which will give me positive 1x minus 1y minus 1z equals a -3. And then I'm going to add those two equations together, and I've planned it. The y's are going to cancel, so I got 3x minus 2z equals -11. So now I have two equations with two unknowns, which we have learned how to do. Okay, so I'm going to write them on top of each other. You're just taking this system of three unknowns down to a system with two unknowns. So I would use the elimination method, and I would get rid of the z's because these are opposites, and all you have to do is multiply the bottom equation by 2 to get the opposite of 4z. So that's -2x plus 4z equals 18. That's equation 1. And then 6x minus 4z equals -22. That's equation 2. And I'm going to add them together, so that's 4x equals -4. So see what I did? Now I have one equation with one unknown. And I can solve for x that way, so divide by 4, and x is -1. So now we're going to go back to find y and z. Now what you want to do is go completely backwards. You don't want to go find a y. You want to go to a place where there is just an x and one other variable. And so in this case it's z. So I'm going to use this equation to find out what z is. So 3 times -1 minus 2z equals -11. So -3 minus 2z equals -11. So I'm going to add 3. -2z equals -8. Divide by -2. And z equals 4. So now I have x known as -1 and z is known as 4. So now I can go to a place to find y, and I'll just go to this top equation. I know x and z, so I'll solve for y by plugging in x as -1, so 2 times -1 plus y minus z, which we know is 4, equals -8. So that's -2 minus 4, that's y minus 6 equals -8. And then add 6 and you get y is -2. So we want to put this as an ordered triple, so the -1 goes first, and then the -2, and then the 4. Now, I'm not going to do it, but if you wanted to check this, you would have to plug -1, -2, 4 in, hit enter, get -8, and you have to check it for all three equations. This one you would just put -1 in for x, which is 2 plus 16, and get 18. Doesn't matter that the y is missing. Okay, so example 2, I definitely don't have enough room here, so I copied it on a sheet of paper. These can take quite a bit of paper, and you want to be very neat. Alright, so this is more like what you might have. This is three equations with three unknowns, and you have no shortcuts. There's no variable missing. So what you're going to have to do is just pick a variable to get rid of, either the x's, the y's, or the z's, and it doesn't matter which one you pick. If you pick if I pick the z's, you might pick the x's. As long as you do it right, it won't matter. I'm going to pick the z's, okay? And the reason is because I see a -z and a positive z, so I already see that equation 1 and 3 are easy to add and cancel the z. So, okay, this gets a little tricky for students. So what we want to do is we want to decide, okay, I'm going to eliminate the z's. So I'm going to just pick equation 1 and 3, just like I said. So equation 1 plus equation 3 are already opposites. Okay, so if I add those together, I get 2x plus 3x is 5x. Okay, 4y plus 2y minus 1y is 6 minus 1 is 5y. And I better write these down So equation 1 and 3. Don't have to multiply anything. They are already opposites. Just kind of copying them down so I don't make any mistakes. Alright, so if I add those together, that's 5x plus 3y equals 3. So by adding equation 1 and 3 together, I got one equation with two unknowns. So I need another equation with the z missing. So that's what we're going to do. We're just going to pick another pair of equations. And you can't pick 1 and 3. I already used that. You could pick 2 and 3 or 1 and 3. I'm going to pick 2 and 3. But this time I have to do a little something, because look at my z's. This is a negative 3z. I need a 3z here. So I'm going to use multiplication to do that. Multiplication is always what you use. So I'm going to add equation 2 plus 3 times equation 3. So I'm going to copy that down. So x plus 2y minus 3z equals negative 4 is equation 2. And if I multiply equation 3 by 3, I get 9x minus 3y plus 3z is equal to 3. Now I'm going to add them together. That's going to give me 10x minus 1y equals negative 1. So what I created now, I went from 3 equations with 3 unknowns down to 2 equations with 2 unknowns. Okay, and I don't want to get lost in it, so I'm just going to copy them down right on top of each other. Here's my new equation 1, and this is my new equation 2. So now I want to solve this system. Well, I think it would be easy to multiply 3 to the second equation and eliminate the y. So first equation doesn't need any changes. And I'm going to multiply both sides by 3. 30x minus 3y equals a negative 3. Add those together and I get 35x equals 0. So divide by 35, you get x is 0. So now I have x is known now, it's 0, so I just want to go back to where there's 2 unknowns with the x. So this top equation here would be good. 5 times 0 plus 3y equals 3 gives me 3y equals 3, gives me y equals 1. Now I know x and y, so I can go anywhere where there's a z. So I'll just take this top equation right here. So 2 times 0 plus 4 times 1 minus z equals 2. 4 minus z equals 2. Negative 4, negative 4. Negative z equals negative 2. Divide by negative 1. And z is 2. Put them in an ordered triple. Check your work. You have 0, 1, 2. Sorry about that. So there's example 2, and hopefully it's not going to be instantaneous for you. You have to practice these. There's just no other way to get better at them, and your head's spinning the first time you see me do this, but there is a logic to it. You want to go from 3 equations to 2 equations with 2 unknowns. So, and it doesn't, you just decide, I'm going to get rid of z. You don't have to get rid of z, but once you make that decision, you know you're going to have to do that twice most of the time. So I picked equation 1 and 3, got rid of the z. Then I went and picked equation 2 and 3, got rid of the z. And that gave me 2 equations with 2 unknowns. Then you get rid of one of the variables there. It just takes a little bit of practice. You can pause this video, copy that problem down, try it, like you've never seen it before, and see if you can do it. It doesn't matter if you do the same problem over and over again. Okay, so I went ahead and told you this is my infinitely many solutions example. It's what's it going to look like when that happens, but it's also not because of the weirdness here. It's also a chance for me to explain the third type of thing that might happen. You might have 3 equations, and equation 1 is missing an x, equation 2 is missing a z, and equation 3 is not missing any of them. I hated these in high school. I didn't understand how to do them until I had to teach it, and then I was like, oh, this is what I'll tell students to do. you want to go from 3 equations with 3 unknowns to 2 equations with 2 unknowns. So you want to know how to do this? Just pick one of these two and stick with it. Okay, so if I pick this equation to use as one of my equations with 2 unknowns, then look at it, it's missing an x, right? So that means I need to take these two and get rid of an x. Okay, so just pick one. I picked one, I circled it, now I know I need to get rid of x. So these two, this is a 2 and this is a -1, so I'm going to multiply this bottom equation by +2 to eliminate the x's. And I like to copy them over again because I don't want to mess up, and I'm just going to put a placeholder for my z. Okay, if I multiply by 2 times -1, I get -2x, and then I get a -4y, and then I get a +2z, and then I get a -2. Sometimes it's good to put your pencil down and just check, because you can make a lot of careless errors. Alright, now I'm going to add. They are 0. That's -1y plus 2z equals 0. And there's my second equation. So now I have 2 equations with 2 unknowns. Okay, so now I'm going to take those two and eliminate either the y or the z. Well, it turns out they're already both opposites. So what happens is, this isn't because of the weirdness of this is just the example that we wanted to show you infinitely many. This cancels, that cancels, so you have placeholder 0 equals 0, and that's a true statement. So again, in high school, you would have said infinitely many solutions, but not here. What we want to do is write set builder notation, and you always go backwards. The z is going to be any real numbers. Y is going to be in terms of z, and x is going to be in terms of z. So what you want to do is just go back to the problem and solve for z. Solve for y. So that would be y equals 2z. Everything's got to be in terms of z. And this one, you could use this one. So watch this. 2x plus 3y equals 2. But everything needs to be in terms of z. So we'll put 2z in place of y, and then I can solve for x. So that's 2x plus 6z equals 2, or 2x equals -6z plus 2. Now when you divide by 2, you got to distribute. As you divide, that's x equals -3z plus 1. So everything is now in terms of z. So this is infinitely many solutions, but it's all the ordered triples, which are infinitely many of them, such that the relationship is x equals -3z plus 1, y equals 2z, and z is any real number. And again, that tells you more. So now I can give you an example. I could let z be 1, then y would be 2, and x would be -2. I could let z be 2, then y would be 4, and -6 plus 1, x would be -5. And this would go on forever and ever. So it tells you more than just infinitely many solutions. Okay, I would definitely recommend you practice, so take a minute to practice these. Take as long as you need to practice. Pause the video and then come back and you can watch me do it. Okay, so this one, if you choose something different than I do, it's going to be hard to follow. But I am going to get rid of the y's. Okay, so I'm going to get rid of the y's. I need to do it twice. Okay, so I'm going to take equation 1 and 2, and I know I need to multiply equation 2 by -1. So I'm going to rewrite equation 1, and students don't often like to write all this over again, but it's really easy for students to make a careless error, so I recommend it. Alright, what I did was I just multiplied equation 2 by negative 1. So this is equation 1 plus a negative 1 times equation 2. I'm just doing this for you. You don't need to write that down. Alright, now I'm going to add and get negative 1x minus 1z equals a negative 5. So I have created one equation with a y missing. That was what I want to do. Now I need to pick two more of these and get rid of the y again. So I'm going to pick equation 2 and 3 this time, but I'm going to need to multiply equation 2. Don't worry that I already multiplied it once by negative 1. Just go back to the beginning. Now I'm going to multiply equation 2 by negative 2. So that would give me negative 4x minus 4y plus 2z equals negative 12. Check your work. Okay, and then equation 3, I don't need to do anything. Let me write down what I did. This is negative 2 times equation 2 plus equation 3. And I get negative 1x minus 1z equals negative 7. So I did it. It took me 2 times, but I have 2 equations with 2 unknowns. Okay, so I'm going to write them together so I can see what I got here. And some of you, I'm sure, already see what I got. Alright, so I want opposites, so I'm going to multiply this bottom equation by negative 1. And I'm not going to rewrite that. When you multiply by negative 1, the signs all change. Okay, so I multiply the equation 2 by negative 1. And then what happens is, that's 0, so 0 pops up as a placeholder on this left side. But over here we have 0 equals 2. Alright, so that's not true. That will never happen, so you're done. This one is no solution. Alright, did you remember the trick for that? You have one equation with 3 unknowns, a second equation missing a y, a third equation missing a z. So how do you do that? Well, my method is just pick one. There. So I'm already halfway done. Now that means I need, this one doesn't have a z, that means I need to use equation 1 and 2 to get rid of the z. So I need to multiply equation 1 both sides by 2 to get opposites. So that would give me 2x plus 6y minus 4z equals 0. And then this one would be 2x plus 0y plus 4z equals 4. And I'm ready to add and get 4x plus 6y equals 4. And then look at that. Those are the same equations. So that's going to be the same line. So that's infinitely many solutions. So do you remember what to do? It's set builder notation. It's going to be all the ordered pairs x, y, and z such that x equals something in terms of z, y equals something in terms of z, and z is all real numbers. So we need to solve for x and y in terms of z. Okay, so this is where you might want to look at this second equation because you have x's in terms of z. So 2x plus 4z equals 4 is 2x equals 4 minus 4z. Divide everybody by 2, so distribute that 2. That's 2 minus 2z. Okay, now you want to get y in terms of z, but this is not z, this is x, but that's okay because you know what x is in terms of z. So I would use this one and substitute 2 minus 2z in for x. So now all I have to do is solve for y. So I have to distribute 8 minus 8z plus 6y equals 4. And I'm going to solve for y. So 6y equals 4 minus 8 plus 8z if I move those two terms over. So that's 6y equals negative 4 plus 8z. divide by 6. And that does not go in perfectly, so what I'm going to do is distribute that. That's negative 4/6 or negative 2/3 plus 8z over 6, which is 4/3 z. So y is negative 2/3 plus 4/3 z, and z is z.